Alright guys, welcome to this page of the notes, and what we're going to do is we're going to take a look at that first type of variation function, which is going to be for us the direct variation. Direct variation, and I give you the formula or the equation for a direct variation function right here. Y equals k. We recognize k. We know that that is our constant of variation. If you were to graph this function, k would be your slope. So y equals k, the constant of variation, times x. Again, I tell you k is the constant of variation, but it's just a fancy way of saying slope in this section. Now let's talk about y. Why is this direct variation? All right, why is this direct variation? Well, keep in mind k is a constant. So let me do this for you real quick. Since k it's a number, right? On the previous page, we saw that k was 3, right? The slope of my direct variation function was 3. Well, 3 is a constant. It's a number that never changes. So in this case, k is going to represent some constant, some number that never changes, whereas y and x are my variables. Those are numbers that can change, and we will change them. But k never changes. It's a constant, the constant of variation. So let's solve for the constant. In which case, and I'm just going to work right here. I'm sorry, I apologize if it's squeezing a little bit for you. You should be able to see. I don't want my highlighter though. Get my marker. There it is. Y equals kx. Well, in order to solve this for k, I just have to divide the x to the other side, and I get k is equal to y divided by x. K equals y over x. Now let's talk about y. This is direct variation. Let's just say, easy example, right? As an easy example, let's just say that k is equal to, I don't know, 2. So we're going to do this for k equals 2. All right? Well, here we go. Let's think of a couple of things that we can choose just as examples that are equal to 2. One just off the top of my head is 4 divided by 2. 4 divided by 2. So if y is equal to 4 and x is equal to 2, 4 divided by 2 gets me 2, my constant of variation. Now looking at one example problem doesn't really help us see anything, but when we look at another example problem, you'll see why it's called direct variation. It's got to be equal to 2. That's my constant of variation. But I need something else that'll get me 2. Well, 8 divided by 4. And now we can begin to see why it's called direct variation. Please notice that my y value was 4. My y value has increased. It's gone up, increased to 8. Right? Increased 8. My x value has gone from being 2 and has also increased to 4, so that 8 divided by 4 is equal to 2. The reason we call it direct variation is because as y increases or decreases, x must also increase or decrease. Both variables must go the same way. They both have to go up in value, or they both have to go down in value, so that we maintain that constant of variation too. Let me show you another one. 2 is equal to 16 divided by 8. Once again, y has increased. I went from 4 to 8 to 16. Y is growing. At the same rate, 2 to 4 to 8, x is growing with it. They both have to go in the same direction so that it's always equal to that value of k. That's why we call it direct variation. They are directly related to each other. Both variables, x and y, directly related, meaning they both have to go the same way. They both have to get bigger or smaller so that I can keep that value of k. All right? Now, one other thing I want to take a look at here are these little guys right down here. I'm kind of working my way through, so stick with me here for a second. I know it looks complicated. I promise I'll explain to you here, and the best way to do that is this. What we're going to do in the problems, exam problems I'm going to give you, is you will be given 2 points. Let's go ahead and call those points x1, comma, y1, and x2, comma, y2. All right, so what you're going to be given is you're going to be given two points, two coordinate points, x, y. We'll call one x1, y1, and the other one x2 and y2. Each of these, right, represents the direct variation for one of those points. Please notice, y equals kx. But I've given them the subscripts y1, x1 to represent this point, right? Remember, k is a constant. It's a number that never changes. So I plug in my y value, I plug in my x value, right? And I could figure out k. If I knew k, plug in the y value, I can figure out x. We'll get that. So this represents that first point. This one over here, again, is the direct variation equation, y equals kx. But now I'm plugging in the x2 and the y2 coordinate, this other point that you have been given. And the idea is this. If you don't know k, I know x1 and y1, I know x2 and y2, but I don't know k. Here's what you do know. It's a constant. It never changes. It doesn't matter what the value of x and y are in this function or in this function, k has to be the same number. It's a constant. So we solve for k, right? Divide the x1 to the other side. y1 divided by x1 is equal to k. Solve for k. Divide x2 to the other side. y2 divided by x2 is equal to k, right? Now that k value is the same. It's a constant. Because k is a constant, what that means is, let's just say y1 divided by x1 is equal to 2. y2 divided by x2 is equal to 2 because both of these functions are equal to the same thing. They're both equal to k. In this example, they're both equal to, like up above, they're both equal to 2. What can you do? You can set them equal to each other, right? They both equal the same thing. So that means that 4 divided by 2 has to be equal to 16 divided by 8. They both come out to be 2, right? So it doesn't matter that I don't know what k is. I can solve the equations for k, set those two things equal to each other because k is the same value, and I wind up with this other form of the direct variation equation. Now, this is the one I'm going to use most of the time, but I am going to show you how to use both of them. Let's take a look at an example problem to see how that's going to work. So here we go. Let me slide up a little bit. Here's the first problem that we're going to work on. And here's what it says. If y varies directly as x, y is equal to 12 when x is negative 13. Find y when x is 16. All right, I know it's direct variation, so that means that y varies directly as x. So I will write my direct variation equation. Y is equal to k times x. Y is equal to k times x. That's my direct variation equation. Y equals kx. Okay, so let's go ahead, right? In this first method, method number 1, I'm going to go ahead and use my direct variation equation and the information that I've been given. I'm told that y is 12 when x is a negative 13. So let's plug that stuff in. Y is equal to 12, which is all equal to k, times a negative 13, right? That's my x and y value. That's what I'm told x and y are equal to. Well, solve for k. That means that k is equal to 12 divided by a negative 13, which is exactly the same as, squeeze a little bit here, equal to a negative 12 13ths. All right, negative 12 13ths. So k is a minus 12 13ths. Now, they ask you to find y when x is equal to 16. And I now know the value of k. So here we go. I'm going to use my direct variation equation. Y equals kx. It doesn't matter that the x value has changed. K is a constant. It will never change. So I'll plug in the value that I know for k, right? I found the value of k, plug it in. They give me a new value of x, plug it in. The only thing I don't know is y, which is what they've asked me to solve for. So we will have y is equal to negative 12/13 times 16, which is my new value for x, 16. Well, calculator will quickly let you figure out that that's equal to negative. I get 192 over 13. So there you go. Y is equal to a negative 192 divided by 13. That's the first method. You can go ahead and use the direct variation equation, which I gave you right up here. Y equals kx, and I use that direct variation equation to go ahead and find this guy. All right. Now, I apologize. I'm going to have to scoot down a little bit into my next problem. I'll erase it when we do this problem. But here's method number 2. Oh, and keep in mind, right, not only did I give you this equation for direct variation, but we then talked about this one, where you're given 2 points, right? The k value is the same, and you can set those guys equal to each other. So this is going to be my second method, and in fact, the one that I am going to use most frequently. Let me still be able to see my problem. So here we go. Method number 2. Here's how it's going to work. I know direct variation is y1 over x1 is equal to y2 over x2, thanks to, right, that what we got up there above by solving each of the formulas for x1, y1 for k, solving x2, y2 for k, and then setting them equal because the k is exactly the same and we wound up with this guy. Well, now it's time to go ahead and, oh, I'm sorry, hold up. I apologize. Actually, let me do this for you. Please notice that my variables have changed. I almost goofed big time. Oh no, I'm sorry. I apologize. I'm still doing this one. I misread it. I'm thinking about the second one. So I still have xy, so that's exactly what we've got. y1 over x1 is equal to y2 over x2. I'll show you in the next problem how we can change the variables. We'll get that in a second. Okay, well, here we go. I know that y is 12 when x is a negative 13. So let's go ahead and plug that stuff in. Y is 12, x is a minus 13. That's all going to be equal to, find y when x is 16. Okay, well, y2 over 16. Now, all you got to do is solve this guy. Please notice the 16 is in the denominator. I will need to multiply that to the other side. Y2 is equal to negative 12/13 over times 16, because I multiply that 16 to the other side. Please notice this is exactly what I wound up with up here. The only difference is I didn't have to find k first and then go back and redo it. By using this formula, I get to it in one shot, and you still wind up with y is equal to minus 192 over 13. All right, so this one down here is the one that I am going to use from now on as we go through these example problems. I'll no longer use method 1. I'll just always use method number 2, where I solve my variation function and then go ahead, set them equal to each other because k is always the same, and we'll solve the problem that way. But if you prefer method number 1, if that one kind of fits your eye a little better, please feel free to use method number 1 if you'd like to. What I'll do in the next video is go ahead and take a look at this second example problem I've got for you here. Please feel free to try it on your own. Come on back and check and see how you did. I'll see you there.